morning, children. In today's class, we are going to learn a few problems on limits. In Standard 11, we have learned the concept of limit with various rules. This year, it is made very easy by a special rule. While applying the lit, can you get 0 by a non-zero number? Yes. 0 by a non-zero number. My answer is 0. It is correct. You can also have a non-zero number by 0. Now my answer is infinity. A very large number, something that is not defined. Now the question is, 0 changes from person to person. 0 means nothing. One person's nothing is different from another person. Infinity tells us everything. One person's everything is different from another person's everything. So this may be one person's infinity, this may be another person's infinity. What is infinity by infinity? Similarly, what is 0 by 0? We have infinity minus infinity, 0 into infinity, a combination of 0 and infinity in various forms. All these cases we call indeterminate forms. We cannot find answer. So when we apply limits, our answer should not become any of these models. Right from lower class, we have learnt 1 power any number is 1. Yes, 1 power any number is 1 only. But 1 power a fraction, 1 power infinity, we have various answers. Already we learnt in complex numbers, 1 power a fraction gives rise to too many answers. In the same way, I can say 1 power infinity is also indeterminate forms. So, when we arrive at all these cases, how are we to proceed with limit? In this year's syllabus, we are learning Hospital's rule, or some people call it as L'Hopital's rule. So, this is the rule that is applied. What is this rule? You have f of x by g of x, limit x tends to a. When I apply, sometimes I may arrive at any of these indeterminate forms. Then I can write it as limit x tends to a. Numerator, let us differentiate f dash of x. Denominator, let us differentiate g dash of x. So, differentiate numerator and denominator separately. This is not u by v form. Do not consider quotient rule for this. Rather, differentiate the numerator separately, differentiate the denominator separately, and then apply the limit. Check whether you get a proper answer. Supposing now also you arrive at indeterminate form, then again you differentiate. Limit x tends to a, f double dash of x by g double dash of x, and we keep on doing till we arrive at a proper limit. As long as we get indeterminate form, we will keep on differentiating numerator separately and denominator separately. So what is the basic to be remembered? This rule can be applied for problems of the pattern, something in the numerator and something in the denominator. As we do exercise problems, let us understand it better. Exercise 7.5 question number 1. Limit x tends to 0, 1 minus cos x by x square. Wherever x is coming, put the limit 0. 1 minus cos 0 by 0. Cos 0, the value is 1. 1 minus 1, 0 by 0, which is indeterminate form. So we are applying L'Hopital's rule. Limit x tends to 0. Differentiate the numerator. 1 will become 0 minus cos x becomes minus sin x divided by x square becomes 2x. This is limit x tends to 0, minus into minus plus sin x by 2x. If I put the limit sin 0 by 2 into 0, which is again 0 by 0, that is indeterminate. So apply the rule once again. So applying Hospital's rule, or I can say L'Hopital's rule. Differentiate the numerator separately and denominator separately. Now sin x will become cos x by 2x will become 2. Wherever x is coming, put the limit 0. Cos 0 by 2, or I get 1 by 2. So now it is not indeterminate form. I have attained a proper limit, and that is the answer. Question number 2. Limit x tends to infinity. 2x square minus 3 by x square minus 5x plus 3. When I put the limit, obviously x square, when I put infinity, it is infinity. Again, this is also infinity. So it is indeterminate form. Applying L'Hopital's rule, we can say limit x tends to infinity. 2 into x square will become 2x. Constant will become 0 by 2x minus 5. Constant becomes 0. Again, if I put the limit, it becomes x becomes infinity, x becomes infinity. So infinity by infinity form. That I call indeterminate. Once again, apply Hospital's rule. I get 2 into 2, x becomes 1, forget it. Denominator, 2x will become 2 and 5 will become 0. We can cancel, so the answer is 2, which is a proper limit, and so for the given question, 2 is the answer. In the first method, we have applied L'Hopital's rule 2 times to arrive at this answer. We will just check this with the 11th standard method. The question is limit x tends to infinity. 2x square minus 3 by x square minus 5x plus 3. The highest degree is x square in the numerator as well as denominator. So divide by x square throughout, or I get limit x tends to infinity, x square out, 2x square by x square minus 3 by x square. Denominator also x square out, x square by x square minus 5x by x square plus 3 by x square. These two I can cancel. These two also I can cancel. Put the limit infinity. Whenever infinity comes in denominator, it becomes 0. So what is my answer? The first term 2. The second term 3 by infinity will become 0. Here I have 1. X and square gets cancelled. 5 by infinity 0 plus 3 by infinity is also 0. Now also my answer is 2. So this is by standard 11 method, and this By this year's method, we are applying L'Hopital's rule. You can try in any method. Question number 3. Limit x tends to infinity x by log x. When you have logarithm and e power in the problems, remember these values. Log infinity is infinity, log 0 minus infinity, and log 1 is 0. The reverse, e power infinity is infinity, e power minus infinity 0, e power 0 is 1. Log and e are reciprocal functions. Let us apply in this problem. X is infinity by log infinity. Log infinity is infinity, and so this is indeterminate form. We are applying L'Hopital's rule. So the rule says differentiate the numerator separately and the denominator separately. X becomes 1, log x becomes 1 by x. Reciprocating, limit x tends to infinity, it becomes x. So what is my answer? Put x infinity. Infinity is my answer. Can you get infinity as your answer? Yes. Infinity by infinity or infinity by 0 or 0 by infinity mustn't come. X becomes infinity, infinity alone can come as your answer. Question number 4. Limit x tends to pi by 2, secant x by tan x. Limit x tends to pi by 2. We shall rewrite. Secant can be written as 1 by cos x. Tan x can be written as sin x by cos x. We can cancel cos x and cos x. So we are left with limit x tends to pi by 2, 1 by sin x. By cos x cancels. Wherever x is coming, put pi by 2. 1 by sin pi by 2. Sin pi by 2 value is 1. 1 by 1 is 1. And 1 is a proper answer. So that is the limit value for the problem. Question number 5. Limit x tends to infinity, e power minus x into root x. So we have to write it as a quotient. Then only we can apply L'Hopital's rule. So the problem can be rewritten as limit x tends to infinity root x by e power x. E power minus x comes down as e power x. Now apply. This is root infinity by e power infinity. This is infinity. E power infinity already we discussed, that is also infinity. And so this becomes indeterminate form. Applying L'Hopital's rule, differentiate the numerator and the denominator separately. Root x, what is the derivative? Root x will become 1 by 2 root x. E power x will become e power x. Now my answer is 1 by 2 root of infinity e power infinity. Denominator infinity is coming. My answer is 0. So fifth question, I have e power infinity is infinity, root infinity. So altogether my answer is 0. Question number 6. Limit x tends to 0, 1 by sin x minus 1 by x. It is better to have quotient model before applying the limit. So taking LCM, this is limit x tends to 0. Denominator is x into sin x. The numerator cross multiply. X minus sin x. As we apply the limit 0 minus 0 by 0. So it is 0 by 0, that is indeterminate form. Applying L'Hopital's rule, differentiate the numerator separately and the denominator separately. We get limit x tends to 0. X will become 1, sin x will become cos x. Denominator, there are two terms. Keep the first term, differentiate the second term. Plus, keep the second term, differentiate the first term. Keep x, sin x will become cos x. Plus, keep sin x, x will become 1. Apply the limits 1 minus cos 0 by 0 into anything 0 plus sin 0 is also 0. We get 1 minus 1 by 0, which is 0 by 0. That is also indeterminate form. So again we are going to apply L'Hopital's rule. Differentiate the numerator separately and the denominator separately. Limit x tends to 0. 1 will become 0 minus cos x will become minus sin x divided by x into cos x. Keep x, cos x will become minus sin x plus keep cos x, x will become 1 plus sin x will become cos x. As I apply the limit, minus into minus plus, sin, wherever x is coming we are putting 0, denominator 0 into anything 0 plus cos 0 plus cos 0. Sin 0 is 0, cos 0 is 1, again it is 1, 0 by 2 is 0, which is a proper answer, and that is the limit value of the problem. Question number 7. Limit x tends to 1 plus 2 by x square minus 1 minus x by x minus 1. Now, when the question is given like this, it is good that we take LCM. Limit x tends to 1 plus. This I can write x plus 1 into x minus 1 minus x by x minus 1. The LCM will be x plus 1 into x minus 1. So we get 2 minus, here x minus 1 present, cross multiply, x into x plus 1. Or we can rewrite it as limit x tends to 1 plus 2 minus x into x, x square minus x into 1, x. Denominator x square minus 1. Wherever x is coming, put 1. This will become 2 minus 1 by 1 minus 1, which is 0 by 0, and it is indeterminate form. So what should we do? Applying L'Hopital's rule. Differentiate the numerator separately and the denominator separately. 2 becomes 0, x square becomes 2x, x becomes 1 divided by x square becomes 2x, constant 1 becomes 0. Now wherever x is coming, we have to put 1. Minus 2 into 1 minus 1 by 2 into 1. That is minus 2 minus 1 together, minus 3 by 2. It is a proper answer, and that is the limit of the problem.